The first section of the last chapter of your high school career of calculus. This actually, today we're going to do. Today we're going to find a clicker that works. Liam, roll over to the board and swipe your finger horizontally on the board, please. Well done. Thank you very much. All right, Liam, you may be my clicker.
Okay.
Be ready.
Yeah.
Okay. So today we're going to talk about separable equations. They're technically called separable differential equations. They're pretty easy, but there are a couple things that we need to make sure you get under control. There's nothing new here except for one small thing, which I will pound into your head until you accept it, but it's just simple antiderivatives. Okay, that's it. So we're not going to make a mountain out of a molehill. We're just going to use the initial conditions to find particular solutions of differential equations. So when you do an antiderivative,
No.
Whoa. Don't get too big for your britches there, Hoss. When you do an antiderivative, normally we have a plus c, which you remember we get an infinite number of possibilities, but we're going to go a little bit deeper and solve for the c term. We've done this already. Okay? It's just a different way to do it. And then also you should be able to drive a stick shift car. Can anybody drive a stick shift? That's it? 4 of you?
I mean, drive is strong.
I'm sorry? Okay. Where did you learn? Either one of you. Very nice.
You want one of these two?
So you drive a stick?
Yeah.
Nice.
My dad taught me.
Good.
My family has a car from my grandpa that's like a 1970s bug. Thing. It's a thing.
It's a thing. You have a thing?
It's called a thing. It's literally
Oh, I know what a thing is.
Yeah, it's bright yellow. It's
Yeah.
banana
You used to
yellow.
be able to paint those. They encourage you to paint them yourselves.
So I learned how to drive it. by
It could be the ugliest vehicle ever created.
It's so ugly, but it's like invincible. And every single person my dad's side of the family has learned to drive. It's an awesome car. It's just like having.
Wait, Liam, I think I solved the problem. Oh, hold on. I didn't solve the problem.
I was worried I was out of a job for a second.
No, you're good to go.
Okay. It's in this economy.
You know what? Let's go back to old school. Today I'm going to teach you guys about film strips. You know what a film strip is?
Yes.
How do you know what a film strip is? You've never seen a film strip before, have you?
It's a little like.
Really?
Yeah.
Oh, all right. So when you used to watch a film strip, it would beep, so you knew when to move on to the next one. Beep. So today we're going to look at general and specific solutions. Beep. As I mentioned earlier, we've done antiderivatives where you get a general solution which involved a plus c, but we've also done it that didn't have a plus c, and those were definite integrals. This is different. We're still doing an indefinite integral, but we're going to solve for the c term. Beep. Beautiful. So let's take something simple. The first line of that equation, I have something called the differential equation, which you can all read, but it says y double prime minus y is equal to 0. One of these two equations, sine of x or c times e of x, satisfies that condition. One of them does not. I hope I did not put the answers on the slideshow. I did not. Good. So with your group, please figure out which one of those satisfies the equation in the first line. I will wait. Talk amongst yourselves.
Is that one of them? Are you doubting this?
Oh, sorry. I thought it was line.
Oh, yeah.
That would be negative sign.
No, it wouldn't, because it'd be negative sign minus sign.
Got it against C. Got it against C.
Because y equals 2 sine, well, negative 2 sine x.
So, yeah.
Okay, you're right.
So then, now, so we know A is not it, but B, wait, it might be.
Well, if A's not right, then it's gotta be.
Wait, no, it is right. Because,
Is it?
yeah, because,
Are you sure?
which is not negative.
I can tell.
Yes, it's not. So.
Let's go! I'm back in business. I fixed the clicker. Liam, you're out of a job.
Oh, man. Oh.
You may have to change your major now.
Oh.
Your major's not clicker anymore.
Yeah.
B. Yes?
Yeah.
Not A. No. Oh, we have an agreeer over here. You think so?
You broke it. Why'd you break it?
Okay, so let's, hold on, let's back up. Leona, you're driving the bus here. What's y prime?
Y prime is like
Is that right? Derivative of sine is negative cosine?
Positive. It's positive.
That's incorrect.
positive. It's the other way around.
Are we sure?
Yeah.
Yes. It's for the derivative of sine is cosine.
Man, do you see what I'm doing here?
Yeah.
So is it positive or negative?
Positive.
Are we sure?
Yes.
Okay, that's what we're going to go with then. I trust you guys. You have honest faces. Leona, what's the derivative of cosine?
And is that negative sign?
I don't know. You tell me. I don't have to know. I never took the AP test. Okay? So we're all in agreement, yes?
Yes.
Does this satisfy this? Negative sine x minus sine x does not equal 0. Well done. A does not work. And because of the way I set up the problem, therefore, obviously part B must work, but let's go through it anyways. What's y prime? Well done. What's y double prime? CE to the x. Just for giggles, what's y triple prime? You guys are so good at pattern recognition. CE to the x minus CE to the x, sure enough, equals 0. Yay! Okay. First type of most basic differential problem, equation I should say. Does it satisfy these conditions? And as we saw, we had one that did and one that didn't, and Liam has the other Liam has a question.
But it could be, the first one could be true if x is 0 to pi, right?
Yes, but it has to work for everything.
Okay, that's right.
Yeah. Yeah, there's certain conditions where it's true, but this is for all conditions. All x's in the domain. Okay. Let's, oh, hey, I did the work already. I could have just clicked. Oh, yeah, just okay, yeah, great. Click, 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 click. Let's get to the fun stuff.
No.
All right, here we go. So this should look familiar. It looks just like the slope field stuff we did. So we can go to our, get out our slope field, draw a bunch of dashes, but we don't care. Here's my question. What function generates that derivative? You can all do that, yes? Good, do it. And then I'll show you the twist. Let's see.
Thank you.
You're welcome.
I can see some people are sure
Hey, let's see.
What is a C?
I don't know. You were the one who said it.
Breaking this, I should have bothered.
I never said anything bad about it. Anyways.
That's true. That's the
Okay, so I'm assuming, in fact, walking around the room, I found that most of you had the correct answer: 1/2 x to the fourth minus 3/2 x squared plus c. Yes? Yes. Outstanding. That's not the new twist. The new twist, which isn't even that big of a twist, you'll notice in the title it says separable differential equations. That first word, separable, is crucial. Okay? So, the dy and the dx, I've used the terms before, is what's called a differential. The differential is the dy or the dx. In an integral, for instance, what purpose does the dx serve? If, for instance, if I had the antiderivative of x squared dx, what purpose does that dx serve? Right?
It shows that that's the variable.
Good. So what would the answer to this problem be?
The 1/3 x squared. I mean x cubed. 1/3. Oh, plus c.
Thank you. What would this be?
Be like 0?
No.
No.
Anyone? Bueller? Anyone? Mr. Dover?
Wouldn't it be just x squared plus?
Ellie?
X squared c.
Outstanding.
C. Plus c.
There you go. X squared z plus c. Okay. So that differential tells you what the variable is. And so I'm guessing what all of you did is you just took the antiderivative of both sides. Yes? Great. And we all got the right answer. Life is grand. However, there is something you must remember to do. And it's, the College Board is overly persnickety about this because they want you to do a separable differential equation. And it's really simple. All you need to do is put all of the one variable on one side with its differential and all the other variables on the other side with its differential. Okay? So this one's easy. That's it. Now you're saying to yourself, why is that a big deal? Well, from a mathematical standpoint, it's crucial when you take the antiderivative of both sides. If I was to just, and what most of you probably did, in a lovely shade of green, is most of you probably just did this guy. Okay? Which makes perfect sense. You take the antiderivative of a derivative, you get back to the function. You take the antiderivative of 2x cubed minus 3x, you get your answer, you stick a plus c on it, everybody's happy. But from a pure standpoint, from a mathematical standpoint, we need to separate the differentials. Okay? To the point where, I'm going to show you an AP question in a second, they will sometimes literally say on the answer key, if you don't separate the differentials, it's 0 out of a gabillion, or whatever, how many points it's worth. Okay? So this seems like I'm splitting hairs, which I am, but it's not my call. Okay? When you look at it this way, however, things fall into a logical progression. What's the antiderivative of dy?
Y.
Y. Now, I heard somebody, did you just say plus c?
No.
Just say yes.
Sure.
Yeah, Duncan just said plus c, and he's right. There should be a plus c. Okay, and then, I forgot, what was this side? 1/2, I struggle with this. 1/2 x to the fourth minus 3/2 x squared plus c. Wait, I got 2 plus c's. Yeah, so the 2 plus c's gets too confusing. So I just want plus c's on one side. So we're going to agree to handle this one way. We're going to just put the plus c's on the x. Well, how can I do that? Well, I can move this plus c to the other side. This will be fun. What's c minus c?
C.
Oh, very nice. C, not 0. Because remember, c can be any constant. So we're going to agree to skip this, this c right there, and we're just going to put the c attached to the x. So we get the same answer. You knew the answer was 1/2 x to the fourth minus 3/2 x squared plus c. There's nothing new there. It's just this little tidbit of separating the differentials that is required while solving these separable differential equations. And there's one other thing we need to talk about, and that is solving for c. This is okay, this is the correct answer, because we don't have any initial conditions. Now, if you go back to the slope field, what did we do? We just found a solution that applies to anywhere on that graph. However, in the next example, click, 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 there you go. I gave you some initial conditions. So what we're going to do is, we're going to solve for the function just like we did on the previous slide. We're going to have a plus c, but then I'm also going to know that when x is equal to 1, y is also equal to 1, so we can get rid of that plus c and just do one of those particular graphs. Questions so far? Good. I'm going to cut you loose. Try that one. All the x's and its differential on one side, all the y's and its differential on the other side. You choose where you want to put the minus sign. There is no wrong place to put it. Well, there is, but it's got to go one way or the other. You pick. Because remember, negative xy is the same thing as negative x over y or x over negative y. Was it grass? Where's matcha? Does anybody know where matcha comes from? 100% my fault. Let me try that again. I don't even know how to ask my question. Ignoring the geographical implications, does anybody know where the product of matcha is derived from?
Matcha.
I think it's the tea leaves, like ground up.
Yes,
which is
tea
why
leaves
it's
ground up.
like as opposed to, it's kind of something.
Let's look at it. We have a whole internet.
It's true.
All these things.
We got this thing called the interwebs, where we can look this up.
Yeah.
Originated in China and developed in Japan, but mostly produced in Japan.
Yeah, but what is it?
Finely ground powder of specially grown and processed green tea leaves.
Learn something new.
Yeah, but like it's like green
So it's like it's
They do actually. What's the smoothie place? Jamba Juice. They have that little patch of grass up on there. You can add some grass. Does anybody know what I'm talking about? At Jamba Juice, you can add some grass to your smoothie.
Okay, but that's like
People do it all the time.
I have that at home.
That's not grass though.
It's like blue wheat grass to my
Both are one.
Wheat grass?
blue wheat.
One equals
Blue,
one over
blue, is it actually?
No, it's green.
It's green.
Integrate both sides. Blue equals the integral with respect to
And what does it do for you?
With respect to x.
You know my dogs eat grass, so
would be one half
their stomach's upset.
plus
Oh, it's just
c.
five.
They
So,
don't
like,
eat
I
grass,
have
they eat it and then grow it up.
Well, right, but that's
Wouldn't it
be one half y?
Okay, let's move on. So this was I'm trying to remember on the slope fields, did we have this or did we have the reciprocal? I don't remember. Well, let's just rock and roll here. When you solved this and you got y, what kind of function is it? Any ideas? Quadratic? Oh, I don't remember, to be honest, that's why I'm asking you. We're gonna solve. It's quadratic? Interesting, okay. pull out your slope field homework and see if you can find that problem.
It's different.
What is it, the reciprocal of it? Y over x? Okay, that screws things up. I should have planned better. All right, well, let's solve this bad boy.
Yes, read. It is on the homework.
It is.
Number 18.
Number 18, what's it look like?
I didn't understand.
Holy guacamole.
He held better than it.
What's the answer to 18?
A.
A. What's the picture in A look like?
A circle.
It's a circle. So it's kind of a quadratic, but they're both quadratic, so we cheated. Y, dy is equal to, did you bring the y with, or sorry, did you bring the negative sign with the y or the negative sign with the x?
X.
Did you all do x?
Yeah.
Okay, that's how we'll roll it. I separated the differentials because it's called the separable differential equation. Take the antiderivative of both sides. So it keeps everything nice and pretty. I've got all the y's with its differential over on the left side. I've got all the x stuff with its differential over on the other side. The antiderivative of y is 1/2 y squared. But again, we're going to skip the plus c because we're going to leave it with the x. And the antiderivative of negative x is?
-1/2 x.
Plus c, thank you. Okay. We're good so far? What's c?
1.
You're correct. Put in 1 for x, put in 1 for y. Everybody see where that came from? Everybody see where that came from? Oh God, I'm killing myself. All right, we're not done yet because I don't have the function. I have a bunch of gobbledygook up there. I've got some y squareds, I got some 1/2 flying all over the place, and I've got a +1 sitting there. The problem is, though, in order to solve the differential equation, you have to solve for y. So solve for y. Let's see what you get.
Let's see.
Oh, I didn't intend that one, sorry. That was an accident. You know what a pirate's favorite letter is?
C.
I did that one already. Okay, we're gonna good here too. The C. Pregunta.
So I started with y is negative, and if I got a different answer for c, and I'm pretty sure it's maybe still.
It's probably the same thing because if you did something like multiply everything by negative, it would flip. Did you get -1 for C?
Yeah.
Yeah.
So it still works.
Yeah.
Okay.
Still work. Everybody is making the same mistake. Well, at least there's comfort in numbers. I mean, not good, everybody's making the same mistake. No, didn't even do it. Good job, Kush. Good job, Kush. Way to leave it blank. Oh, we have a winner! Yeah! Okay, so let's talk about this for a second because this type of problem happens all the time, and frequently the College Board will try to kind of snooker you into getting it wrong. When we have that equation, if I moved the x squared to the other side, I would have 1/2 x squared plus 1/2 y squared equals a number. In this case, it would be 1, and that's the equation for a circle. It's a circle with the center at 0, 0, and a radius of square root of 2. Okay. Now, you don't need to know that, but what you do need to know is that in order to get that circle, you need the plus or minus. Okay? That's why the difference between x equals y squared and y equals the square root of x is relevant. Okay, so now that seems like a sidebar, but let me talk about that for a second. Are these the same thing? Good. Way to say yes and no right after one another, so you're correct either way. What's the top one look like? Stop talking, please. What's the top blue one look like? Yeah, it's this. What's the bottom one look like? It's a sideways parabola. Because in the bottom one, when you solve for y, you're implying that the plus or minus becomes relevant. So without this plus or minus, we're talking about the top part or the bottom part of the whole of the circle, and we want the whole circle, so you need the plus or minus. However, now you need to make a decision. And the decision is you can't have plus or minus. So I'm being contradictory here. When you take the square root of y, you get plus or minus, but now you have to make a decision on one or the other, because there is a definitive answer. Is it positive or is it negative? And the answer is it's positive. Why? Nick?
Because the 0.11.
Beautiful. In our initial conditions, it tells us that y, this whole business that we're talking about, takes place at that point. And at that point, y is positive. So therefore, our final answer becomes y equals the square root of negative x squared plus 1. Plus 2, I mean. So you're saying to yourself, hold on, you big dope. I had that and you said it was wrong. But it's not. Because what they're going to do is they're going to test you. Now what they like to do is they like to set this y value up so that it's negative. And therefore not getting this. You would have the minus sign in there. Or they like to give you credit for saying that it's plus or minus and then expecting you to figure out that it's positive. Okay. So this initial condition will determine the sign on that function. Okay. Can't be both, because if it's both, we don't longer have a function. Questions? So other than this whole plus or minus gunk up here, all of this is just repeat as long as you remember to separate the differentials. Okay? We're good? All right, so this is 2006, number 5, AP question. And it combines the last 2 days of classes together. This is a very common type of problem. So I'm going to kind of talk you through it, then let you work on it for a second, for a little while, and then I'll show you the grading rubric. And you can figure out how many of the 9 points you would get on this thing. Okay? So, we have a differential equation, meaning you're given a derivative of some function. You have no idea what the function is, but I do know the derivative is 1 plus y over x. And they sneak in this little thing that x can't be equal to 0. That's just there to cover their butts. Then they ask you to do a slope field. You'll notice on that slope field there are only 1, 2, 3, 4, 5, 6, 7, 8 dots. And they were very kind to you here in that they didn't put dots on the y-axis. Why? W-H-Y, not y, the letter. Beautiful. X can't be 0. So part A, they want you to draw a slope field for that differential equation. Part B is what we just did. These two questions, these two parts, A and B, will count for 9 points. This is an AP question. So I'm going to give you, let's say, like 6 or 7 minutes with your group to try and solve that, and then we'll do like a mini grading here to see how you would have done. How many of the 9 points can you get? Now, before you get started, this is my thought. When this pops up, this should be a guaranteed 1, 2, or 3 points. Okay, it's not that tough to draw dashes on a slope field. Take your time and figure out your values correctly. The meat and potatoes is down in B, but this isn't that difficult. You can manage it. Okay. Any questions? The math gets a little ugly in this one, but it's an AP question. You'll be okay. Go.
You're not approaching 0.
Because you take 1 and you add 1 it's equal to 0. Use the axes provided in the Dover, is it I forget the order. It works. It's not really. It's the order. Say something, say something. Say something, see something.
Over there? That one?
No, no.
That's just general. That's just general.
When did you know?
What does it say? See something.
Other way around.
See something.
We'll try it again. Think about it. Yeah.
I don't.
Stay your head right Yes, there's one minus one.
I'm just not really aware of some questions.
Be like, yeah, 1 plus 1 over negative 1. That'll just be like, or negative 1, sorry. Or sorry, negative 2. You know, I can do math.
We have 3 other elements here.
What?
No,
1 plus
1
1
is
is
0.
2. Over negative 1 is negative 2.
1 over 1.
Yeah.
What is that?
There's a 1 over 1. Dover, you're just not doing
Yeah.
Oh, it's also
Dover is
we've been over it.
Yeah.
I feel like I was like, oh no,
It's not calculated. It's number 5, so only 1 and 2 are calculated.
solve it.
What is the integral of some integral negative 1?
actually it's not 1 plus 5.
So, Okay, so how do we define y plus y equals ln x plus
You divide both sides by y, and then multiply both sides by dx. It's not 1 plus y. It's not, I promise you, it's not 1 over 1 plus y.
Well, this one here equals 1 over x. So if you divide by, okay, if you divide this by y, it's not gonna just get 1 plus y.
You're trying to just get y over it. Wait,
But you can't.
remember, so blacks every generator.
1 plus 1 divided by y is not equal to 1. It's equal to 1 plus y divided by y. So you use this.
I do not. I promise.
Remember, I said this.
dy over 1 plus y.
It affects the most progressive. It affects the most progressive. It's not easy. How many gens? There's 7 gens. So it affects 7. It's not, it affects 1 gen. It's the most progressive gen. And it affects the gen.
Why would they should make a this means like dx times x negative 1 technically. And this is dy. This one for us takes y is like 1, 2,
It's just like a
and then you would carry that and then you put around that it's like
It's
negative
kind of like a regression. It's kind of like a regression.
and y negative
Progression, but not on a gen.
It's
120%.
It's basically like old version.
So that's correct.
Is there name's still short on the back. Can you explain me again?
Oh, I thought you did.
Like prestige. Prestige one.
But then you get like y plus y.
Lee wants to know why.
It's not productive. It's a pretty solid attack.
Listen, man. I'm thinking because that would be 0.
It's just like festering.
I know, it'd be terrible.
We actually write the exercise.
Why do we need
Alright, let's go 3 more minutes at 2:30. I'll show you the answer so you can see what you did or didn't do right.
Oh, L1 is 0.
That's not possible.
Hold on.
Oh
my god, I was right. I was right. Wait, oh my god.
The one he says
You belittled me for a fool like Galileus. But I was right all along. I don't know.
I was persecuted for saying the truth. This is the start of my section.
That's not right.
y equals
What's ln of ln of 1 is 0, correct?
so c equals ln2.
Oh, you just made that line perfect.
Guys.
Whenever
you
so like when you're thinking to yourself in your head, you realize whenever you're writing, you take the square root. You're like,
No, I did take it. No, I did take it.
You just didn't write it.
So minus 1 pi.
okay, but okay, so if you take the integral of 1 over 1 plus y,
You wrote so then. No, because this is the x value.
1 hour rocket league.
Oh, we got
I'll get some.
Okay.
Tolerance also like your
Negative for y plus c, but then never.
Yeah, it should be y, y minus.
It is the best game. We still gotta play once. The more you play once, the better you get it. That's how we gotta ask anyone who's hired.
The more rapidly you play, the better you get.
What is the
Playing one is not.
you do you? No,
Because actually, not
I cannot do you. I cannot. I must not do you. It's how we play. I cannot do you.
Yes.
Why is it
Playing
feel like
one,
putting these
I'm
in?
better at one.
It is officially 2:30, let's take a look, kids. Now, walking around the room, I saw that many of you did the initial stages of this problem. Remember, I talked about this briefly. I've talked about this briefly with the AP questions. Almost all of you, on almost all of the problems, will not get anywhere near a 9. Okay? That's the harsh reality. So your job is to get as close to 9 as possible. Or, if you can't get close to 9 on a problem, or if a problem blows you out of the water, you need to make up for it on the other questions. This is a problem that when it shows up on the AP test, you should probably get a 7 or an 8 on it. Maybe a 9 if you're feeling all fancies in your pantsies. Okay? Because there's going to be a problem where you're going to get a 1 or a 2 on it, maybe a 0. There are some that just are going to kill you. And you'll see in a month or so when we start reviewing what I'm talking about. And that's nothing to panic about. And even on this problem, some of you during the AP test, if this problem comes up, you might only get a 1 or a 2 on this. However, as long as you compensate that with a 7, 8, or 9 on another problem, you're good to go. Okay, so let's talk about how to solve this. And again, remember, you're battling for points. So small things make a difference. What I would suggest, if you did your work, let's say in green, switch to a different color and grade it somehow. If you used every color in the rainbow, you're kind of out of luck. Okay, so let's talk about there's 2 things I want to show you here. One is the obvious answers. They're not obvious, but the answers is one of them I want to show you. And the other one is the grading rubric on how these numbers are determined. So notice on the slope field, check the numbers on the slope, or check your dashes on the slope field and see if you did it right. It should look something like that. And they intentionally picked a problem or an equation or a differential equation that you're not going to easily know what the shape of it is. Now, you get 2 points for doing that correctly. If the signs of the slopes at each point and the relative steepness of the slopes in rows and columns are correct, you get 2 points. Okay? In other words, are these horizontal? Do these start to slant a little bit more? Are these steeper up on top? Okay? Are these positive and these negative? If you satisfy both conditions, then you got yourself an easy 2 points. And that's what I'm talking about with this type of problem, is that hopefully the slope field is easy peasy. You don't have to do that many little dashes, and they're pretty straightforward because it's just a plug and chug. Any questions on that? Okay, now let's get into the fun. I want to focus on how to solve the problem first, and then we'll talk about the grading in a second. Okay. So, walking around the room, it seemed that most of you solved the equation by cross multiplying. Now, some of you had it upside down. That's okay. Just flip it over, because we need to have the dy and the dx. A lot of you had dx over x, or dy over 1 plus y, which is fine. I find it easier to see or to work with if you write it the way they did. 1 over x dx. Okay.
What's
Problem so far?
What's the difference between K and C here?
I'll get there in a second. Okay. So the antiderivative of 1 over x is the natural log of the absolute value of x, which we'll talk about in a second. And the antiderivative of 1 over 1 plus y is the natural log of 1 plus y. Now, the reason I picked this problem is because something happens here that I want you to be aware of. This lulls you into thinking that if you have this as a function, and I take the antiderivative of that, it makes you think that anytime you have 1 over something and you take the antiderivative of it, it's the natural log of that something. Which is not true. Okay. They made a big jump here. They didn't necessarily show you how that was done, but that needs to be done as a UDU problem. What's U? 1 plus y. Okay. Which in this case it's okay, because the 1 plus y, when you take the derivative of it, is just y. Sorry, I lied. It's just 1. And so it doesn't become a big deal. If you didn't realize that this isn't how it works, you can still BS your way through it and get that as an answer. Okay, but I want you to be careful that anytime you see 1 over something, the antiderivative of that is not the natural log of that something. You got to do a UDU. Okay, now the reason they have a K and a C is because that's how they chose to distinguish between the different limits or constants of integration. Okay, so when you take the antiderivative of both sides, remember we chose to put the constant of integration on the x side, and so they called it K. And then they solved that. And how did they solve it? This also requires a little bit of explanation here, because we haven't really done this yet. So they used a trick that you probably should have worked on in pre-calc, I hope, and that is solving natural log problems by taking the e, or raising it to the e of both sides. Do you know that trick? Does everybody know that trick, yes or no?
Yeah.
Yeah, okay, so what they did here is they said, all right, I'm going to do this, and I'm going to do this, and I'm going to put that in parentheses because it's the whole thing. You'll notice from the second step to the third step, sorry, let me back up. From the third step to the fourth step, things got a little crazy. How did I go from the third step to the fourth step? Well, this, e to the natural log of anything cancels and leaves it as itself. E to the natural log, this is a problem here. Because that's a sum, that's not a product, it's not a whole thing. So they changed that whole natural log of k thing into this variable they call c. Now how did they do that? Well, this is the same thing as yes or no? Let me simplify it for you. What's x squared times x cubed? X to the fifth. We add exponents. So we're going the other way. We're taking that exponent, which is a sum, and breaking it into two different things. Okay. This is a constant k. So what's e to the k? E to the k, or just c. It's some constant. It doesn't matter. K can be anything. So you'll notice that this c value, this e to the k value became this c. I know this seems very confusing. You'll get better at this as you practice. Where did the absolute value of x come from? The absolute value of x came from this guy. E to the natural log of the absolute value of k. Those cancel out and leave you with the absolute value of x. Okay? Do I need to go through that again, or are you okay? Because that's going to happen a lot. We're good. Okay, then you plug and chug, and you find c is 2. There's no square root here, so you don't have to worry about plus or minus. You just solve for y, and you're good. Okay. And again, I know you're confused on that. That's okay. Let's talk about the grading. First of all, I want to jump down to this. And this is why I'm making such a big deal out of that. If you do all that work correctly, and you forget to put the dy on one side and the dx on the other side, they will give you no points. which seems harsh, but that's how they roll. If you forget to put a plus C somewhere, you're going to get only 3 of 6, no matter how correct you are. Okay, so let's talk about how you get these 6 points here. Number 1, you get a point for separating the variables. If you put the dy's on one side and the dx's on the other, you get a point. Taking the antiderivatives correctly gets you 2 more points. Okay, did you know how to take the antiderivative of 1 over 1 plus y? Did you know how to take the antiderivative of 1 over x? I'm sure most of you, if not all of you, did, so that's another 2 points. Did you include a constant of integration? Is that k term there, which you probably called a c? If it is, you get another point. Did you use the initial conditions correctly? Now, what does that mean? That means if you plugged in the right numbers for x and y, whether your work is all wrong or not, if you went back to this problem and said, oh yeah, I know that x is -1 and y is 1, if you plug that in, you get another point. And then, lastly, did you solve for y correctly? Okay, now at some point they're expecting some correctness, and that's where this last point comes into play. And then, just to be a bunch of jerks, they threw this domain thing in here, which has to do with the absolute value. We can talk about that absolute value later. That's not really what I wanted to focus on. I wanted to focus on the importance of separating the variables and how these problems work when you have those kind of functions.
So they both say if x is less than 0. Should one of those be?
Did they make a typo on their? No. What they're saying is the domain x has to be less than 0.
Oh.
X can't be greater than 0 because you end up taking a natural logarithm negative number.
Oh yeah.
Okay. This is the first time you're seeing a problem like this. You will see more of them, and we'll practice these a lot because there's a pretty good chance that something like this is going to show up on the test. And on the test, if you just look at how those points are generated, I would expect all of you to get at least a minimum of 6 points? 7 points? Okay. Now, how am I saying that? Well, here's what I believe. See, having watched you do your work, I think this is a slam dunk. Now, you're going to need to practice slope fields a little bit more because they're probably going to throw something wonky at you. But, okay, slam dunk for 2 points. Hopefully, I'm going to burn that into your brain enough where you're going to have to separate the variables. That's another easy point. You can all do antiderivatives now. That's another 2 points. And all you got to remember is stick a plus C on there somewhere for another point. And then I'm guessing probably you can do this too because you realize that on the directions, this is the initial conditions. You plugged in -1 for x and 1 in for y. Okay? Even if the wheels fall off the bus after that point, you can't solve for y. Whatever happens, I'm feeling good that most of you, if not all of you, can get a 7 on a problem like this. And there's a lot of little places to make mistakes, but some of these are brainless. Okay? Just separate the variables. Easy peasy. You can do antiderivatives now. Just remember to stick a plus C on there and then plug in the initial condition. Okay? Does that make sense? Question here in the front.
Do you have to have the stuff right for like the initial conditions point and stuff? Like, do you have to do that correctly, or do you have to do the antiderivative correctly to get that?
Yeah, they don't just give you points for...
Well, like if you do the antiderivative wrong, you add
The implication is that those are the antiderivatives done correctly.
For the constant of integration.
I mean, would you get the initial condition thing right if you did?
If you plugged in -1 for x and you plugged in 1 for y, regardless of how badly you screwed up on the antiderivatives, yes.
Okay.
I will say this, the College Board does a really nice job of eliminating the snowball effect. You understand what I mean by that? Snowball rolling down the hill starts to build up more and more snow and gets bigger and bigger. So what they do is they do a good job of not penalizing you for earlier mistakes. So if you completely screw this up, but you plug in -1 for x and 1 for y, you can still get that. Unless, of course, you know, there are some caveats in there that don't do this or we're not going to play nice. Okay? Questions? Okay. The last thing I have for you are a bunch of nerds out on a playground making a slope field. Which we can go out and do that too when the weather gets nice. It'll be fun.
Imagine like you see just like.
I'm gonna be honest with you, Abby, when you get to be my age, you don't care how people look at you.
No, just like, I would think it would look weird.
We should make one big slide.
So you wouldn't go, you wouldn't go and do it? Okay. Would anybody not go outside and do a slope field?
I would just be laughing.
Okay. Alright. Good. It'd be an excuse to go outside. We're not gonna do it today.
We should do a lesson outside.
We should do a lesson outside. Let's do that. When the weather's nicer.
Right now, like when it's raining.
No, well, I mean, this is kind of waterproof, so I'd be good. Go here. No, over here.